Every year, over 27 billion square feet of drywall are produced in the United States. That's enough to build a road from the Earth to the Moon and almost halfway back, or to cover the entire state of Delaware twice. But how does an ordinary stone, formed millions of years ago at the bottom of ancient seas, turn into the smooth sheets that become the walls of our homes today? In this video, we'll take a look behind the factory doors, where tons of stone pass through furnaces, mills, and conveyors to become the symbol of modern American construction. Watch until the end, and you'll see secrets that are rarely shown publicly.
The numbers behind drywall production in the United States are not just big, they are astronomical. And they tell a story of how the country builds, renovates, and breathes. In a recent year, factories in the US produced approximately 27 billion square feet of gypsum board panels. This number is so colossal that it's hard to comprehend. Try to imagine, if you were to lay out all this amount of drywall, you could create a continuous 3-foot wide path that would stretch from the Earth to the Moon and almost halfway back. Or, with this number of sheets, you could completely cover the entire state of Delaware twice and still have some left over. This endless stream of building material is not only a physical product, but also a powerful economic indicator.
The market for these panels in the US is valued in the tens of billions of dollars, reflecting not just the cost of the material itself, but also thousands of jobs in mines and factories, in logistics and in construction. It all begins not in the workshop, but much earlier, in a quarry where gypsum is mined. This is a natural mineral, a stone that was formed millions of years ago from ancient seas. It can be white, grayish, sometimes with pink veins. Huge excavators dig into the gypsum deposits and load dump trucks with boulders of this stone. These trucks bring tons of gypsum to the factory and dump it onto the raw material yard, creating entire mountains waiting for their transformation. The first stage inside the factory is coarse crushing. The gypsum boulders fall into the giant steel jaws of the primary crusher.
With a deafening roar and grinding, the machine breaks the large stones into smaller pieces, the size of a fist. This is just the beginning. Then, this crushed gypsum is fed by a conveyor belt to secondary mills. Here, dozens of steel hammers, rotating at an insane speed, break these pieces into even smaller fractions, turning them into something resembling coarse gravel. But even this is not enough. The final stage of grinding turns the gypsum into a fine, powder-like dust. It becomes so fine that it resembles flour or dust. This powder is the main raw material, but it still hides a secret that needs to be revealed. The next step is one of the most important and interesting. It's a process called calcination, and essentially, it's the controlled drying of gypsum. The fact is that in the crystal structure of natural gypsum, water molecules are locked in. For drywall to harden, this water must be temporarily driven out. To do this, the white powder is fed into a huge, slowly rotating kiln. It looks like a giant drum tilted at a slight angle. Inside this kiln, a very precise temperature of about 300 degrees Fahrenheit is maintained. The gypsum powder, slowly tumbling inside the drum, heats up and the water bound to it turns into steam and evaporates. Chemically speaking, gypsum turns into calcium sulfate hemihydrate. But to put it simply, it becomes thirsty. Now this powder, which is already called building plaster or stucco, has a unique property. If you add water to it again, it will greedily absorb it and turn back into a hard gypsum stone. It is this property that is the basis of the entire production. The resulting hot powder is cooled and stored in giant silos, resembling towers, from where it will be fed to the main production line.
And now the most spectacular part begins, the creation of the sheet itself. In the workshop is a huge conveyor, hundreds of feet long. At its beginning stand 2 giant rolls of special dense paper, or paperboard. One roll for the face side, it's perfectly smooth, white. The other for the back side. It can be a bit darker, grayish. The ribbon from the bottom roll, the face side, is unwound and lays on the conveyor, forming an endless track. In parallel with this, in a giant mixer, resembling an industrial food processor, the core is prepared. Our thirsty gypsum powder, water, and a whole cocktail of various additives are continuously fed into it.
Each additive plays its role. Foaming agents make the gypsum mass lighter and more porous, like whipped cream, to reduce the weight of the sheet. Plasticizers make the mixture more fluid, so it spreads evenly. Accelerators or retarders allow engineers to perfectly control the time it takes for the gypsum to set. Starch helps the gypsum core to stick better to the paper liner, and fiberglass adds strength. This mixture, called slurry, resembles a thick gray porridge. It is poured in a continuous stream directly onto the paper ribbon moving on the conveyor. Special devices evenly distribute this mass across the entire width of the paper. The edges of the bottom sheet of paper are neatly folded up, forming the sides of the future sheet. And at this moment, the second ribbon of paper, from the back roll, is laid on top like a lid. The result is an endless, perfectly even sandwich. Paper, gypsum mass, paper. This sandwich immediately passes between 2 rollers or under a forming plate, which compress it to a precisely specified thickness, for example, ½ inch. The newly formed, still soft and damp sheet of drywall continues its journey on a very long conveyor called the setting line. Its length can reach several hundred feet. While the sheet slowly moves, a real miracle is happening inside it. The gypsum powder reacts with water, the same rehydration reaction occurs. The gypsum turns back into a hard stone, releasing heat in the process. If you touch the sheet at this stage, it will be warm. In a few minutes, the loose mass becomes hard enough to hold its shape. At the end of this long line stands a flying knife. This is a huge blade that moves in sync with the belt, and at the right moment makes a quick, precise cut, slicing the endless sandwich into sheets of standard length, for example, 8 or 12 feet. This happens so quickly that the conveyor doesn't stop for a second. The cut sheets are now hard, but still very damp. They contain excess water that did not participate in the chemical reaction. It needs to be removed. Therefore, a special device flips the sheets and feeds them into the most massive structure in the factory, a multi-deck drying kiln. This is a giant labyrinth consisting of several levels, each of which is a conveyor. The drywall sheets slowly move along these levels back and forth, traveling a path of several hundred feet inside this huge furnace.
Hot air circulating inside gently evaporates the excess moisture from them. The temperature here is very carefully controlled. Only the free water needs to be removed without damaging the crystal structure of the gypsum itself. This process can take about an hour. At the exit of the dryer appears a product we are familiar with, a perfectly dry, light, and strong sheet of drywall. But this is not the end. The final stage is finishing. 2 finished sheets are stacked face to face, their edges are perfectly trimmed to be straight and clean. A paper tape with information about the manufacturer and product type is glued to the end. After this, robotic manipulators with superhuman precision and grace lift the finished sheets and stack them in perfectly even stacks on pallets. Each stack is wrapped in protective film, labeled, and sent to the warehouse. From there, it will go to construction sites to become part of someone's home, transforming from a simple gray stone mined from the earth into a smooth and cozy wall. Drywall production is like a barometer of the construction industry's health. When the economy is booming, people actively build new houses and renovate old ones, and the demand for drywall soars. The factories that produce this product operate at full capacity, and the stream of trucks delivering the finished sheets across the country becomes endless.
The heart of this production beats in unison with the rhythm of the real estate market. Geographically, this industry also has its centers. Although drywall factories are located throughout the country to be closer to large construction markets, the extraction of the main raw material, gypsum, is concentrated in certain states. The leaders here are states like Texas, Oklahoma, Kansas, Nevada, and Iowa.
Every year, humanity discards more than 10 million tons of electronic waste. Of this, hundreds of thousands of tons are televisions, packed with precious metals, complex plastics, and even deadly toxic substances. But what happens to them after they leave our homes? Did you know that inside one old, bulky television set lies pure gold, silver, and components that could become the heart of new gadgets? This isn't just recycling. This is a high-tech treasure hunt. Today, we'll show you how the most advanced recycling facilities operate and why this process matters more than you might think. It all starts not at the factory, but in our homes and offices. Old, outdated devices are collected at specialized reception stations. In developed countries, this is a well-oiled system, from dedicated containers in supermarkets to trade-in programs run by major retailers. Modern recycling centers aren't grim rubbish tips, but gleaming high-tech facilities. Their primary goal is to extract all reusable materials as efficiently as possible, while safely neutralizing the toxic components hidden inside. At large-scale operations, television recycling is organized along automated production lines, where most processes are carried out by machines rather than people. The first stage at the facility is the medical examination and sorting. Televisions are separated into three main categories: bulky cathode ray tube monsters from the past, slimmer plasma panels, and modern liquid crystal displays. Each type requires its own entirely unique approach. Then the undressing begins. Robotic manipulators or workers strip away the plastic casings. This plastic is immediately sent to giant shredders where it's ground into tiny fragments which, after remelting, will become parts for new motor cars or casings for other electronics. Metal frames and fixings are also separated and sent to their own recycling line. Once the casing is removed, the defenseless innards of the television move on to the dismantling line. Old cathode ray tube televisions receive particular attention. They can genuinely be described as environmental dirty bombs. The most hazardous component is the cathode ray tube itself. It contains up to several kilograms of lead, which was used to prevent X-ray radiation, whilst the internal surface is coated with a layer of phosphor containing toxic rare earth metals. Consequently, they're dismantled with exceptional care, often by hand, within sealed chambers. First, a specialized heated wire or laser carefully separates the front clean glass from the rear lead-laden funnel. The glass is then cleaned, crushed, and sent for recycling, whilst the lead is extracted for manufacturing new batteries. Modern liquid crystal displays are no less hazardous. Hidden along the edges of the panel, thin as spaghetti, are fluorescent backlight tubes. Each of these tubes contains a small but highly dangerous amount of mercury. That's why LCD panels are dismantled in specially sealed boxes with powerful ventilation systems. Robotic arms or workers in protective suits carefully extract these tubes. They're placed in hermetically sealed containers and sent to specialized facilities where the mercury is safely extracted and purified for reuse. The liquid crystals sandwiched between the glass layers present another challenging component. They're extracted using chemical solvents. Plasma panels require their own approach. Unlike LCD displays, they don't contain mercury, but their cells use inert gases such as xenon and neon. The panels are dismantled, the gases are collected in special containers for reuse, whilst the high-quality glass that makes up the screen is crushed and purified. Once the screens and casings have been neutralized and sent on their separate ways, the most valuable parts remain on the conveyor belt, the circuit boards. This is where the precious metals are hidden. Copper wires, aluminum heat sinks, and other metallic components are separated and sent off for smelting. The most important and complex part is processing the printed circuit boards. It's in these boards, within the microchips and connectors, that you'll find microscopic yet incredibly valuable quantities of gold, silver, palladium, and other precious metals. First, the boards are shredded into fine particles. These particles are then sent to the chemical workshops. The most common extraction method is chemical leaching. The shredded boards are immersed in special acid solutions. To extract gold, they often use aqua regia, a mixture of concentrated hydrochloric and nitric acids, which can dissolve even this noble metal. After the precious metals have dissolved into the solution, the precipitation process begins. Special chemical substances are added to the liquid, which cause the pure metals to fall out as sediment. For instance, ferrous sulfate is used to precipitate gold. This gold sediment is then thoroughly washed, dried, and remelted into small but incredibly valuable ingots. Similar methods are employed to extract copper and silver, though using different, less aggressive acids or the electrolysis method. In the final stage, all the recovered materials, gold, copper, aluminum, glass, and plastic, are compressed into compact blocks. Each year, millions upon millions of televisions are discarded worldwide, with their combined weight running into millions of tons. In Europe alone, for instance, electronic waste exceeds 10 million tons annually, and a substantial portion of that comprises televisions and monitors. This staggering figure isn't merely a statistic, it's testament to our rapid technological advancement and its darker consequences. But there is encouraging news. Year on year, growing numbers of people are recognizing the importance of proper disposal. Hundreds of thousands of tons of old televisions now find their way to recycling facilities each year, helping us preserve our air, water, and finite natural resources. Here's what the real secret we mentioned at the beginning is all about. Your old television isn't rubbish, it's a genuine urban mine. A single ton of old circuit boards contains 40 to 50 times more gold than a ton of gold ore extracted from a traditional mine. Electronics recycling isn't simply about caring for the environment, it's an incredibly profitable business of the future. We've learned to extract the most valuable resources not from beneath the ground, but from what we ourselves have created and discarded. And every time you take an old television for recycling, you're not just getting rid of clutter. You're returning precious metals to the economy and helping to make our world a bit cleaner.